Many of you may be familiar with piecewise functions, but some of you may not be familiar at all. So at the end of this lesson, you'll be able to describe what a piecewise function is, as well as evaluate and graph a piecewise function. All right, first of all, let's just take a look at what piecewise functions look like in equation form and graph form. If you'll notice, if you look at the picture, a piecewise function basically just has graphs in pieces. So if you look at this first graph, you'll notice that in this first section we've got a parabola going on, and then we've got a straight line, and then we've just got a dot, and then we've got some other funky graph going on. Now the way that this would be described is from probably negative infinity up till we get to -1 on the x-axis, we've got the parabola. Then from -1 to 1, we've got another graph going on. Then at 1, we have just a dot. And then from 1 continuing onward, we've got something else. So the graph appears in pieces. Same thing if you look at the function in function notation, depending if x is less than 1, or if x is between 1 and 5, or if x is greater than 5, different things are happening. You get different graphs. So that's what we're going to be dealing with when we deal with piecewise functions. We're going to evaluate them, and then we'll also graph them. Okay, so if we're evaluating a piecewise function, this is a piecewise function, and there are two pieces. We have the equation 5/2 x plus 3 when x is less than -6, and then we have the graph f of x equals 3x minus 1 when x is greater than -6. So we are going to evaluate. The first thing, let's say I ask you to evaluate f of 2. Okay, the first thing that you need to decide is which piece am I going to plug the information into. So we're looking at an x value of 2. So we just need to ask ourselves, is our x value less than -6, or is our x value greater than or equal to -6? And we know that 2 is greater than or equal to -6, so we're going to use the second piece. So we're going to be using 3x minus 1. And now we're just going to evaluate like we're used to evaluating. Plug 2 in, so we're going to have 3 times 2 minus 1, and that will give us a value of 5. So f of 2 is equal to 5. And then our next example, let's say I would like to do f of -3. Okay, so we are going to, let's not do -3, let's do -8. How about? So if I do f of -8, what we are going to be looking for is which piece am I going to get to use? Is -8 less than -6, or is -8 greater than or equal to -6? And in this case, -8 is less than -6, so we're going to use the first piece. So the function we'll be referring to is 5/2 x plus 3. So then we can just plug in -8. So 5/2 times -8 plus 3. And then 5/2 times -8 is -20 plus 3. My answer will be -17. So f of -8 will equal -17. And I'm going to do one more. If I do f of -6, we have to decide which one of those am I going to plug it into. And I notice the second piece, that has the equal. So when -6 equals -6, that's the function we're going to plug it into. So we're going to take 3x minus 1. I can go ahead and plug -6 in, and then we will get -19. So we would know that f of -6 is equal to -19. Okay, now graphing a piecewise function, we just need to pay attention to the parts. So notice we are going to get the function 4x minus 6 when x is less than 4, and we'll graph the function -2x plus 6 when x is greater than or equal to 4. So basically what I like to do is just do two separate graphs, and then we'll connect them into one graph when we're done. One thing that is nice to notice is that I can tell that both of these are lines when I'm doing my graphs. So the first thing that we basically have is we have 4x minus 6 for one of our graphs, and then we have -2x plus 6 for our other graph. Okay, for each of these, just to make it easier, we are going to make x-y tables, and I'd suggest you do that as well. It just makes it a little bit easier, and we know they're going to look like a line. So this first one is when x is less than 4. So we're just going to start at 4 for both of them, because that's when both things, something different is happening. This first one, we want to be x is less than 4, so I'm just going to write down some values of x less than 4. So 4, 3, 2, that should be fine. And then the next one, we need x is greater than or equal to 4. So 4, 5, 6. All right, and then we'll just go ahead and plug things into our formula. So if I plug 4 in up here, 4 times 4 is 16 minus 6 is 10. 4 times 3 is 12 minus 6 is 6. 4 times 2 is 8 minus 6 is 2. All right, and then we'll go ahead into the next one. We'll plug in 4. -2 times 4 is -8 plus 6 is -2. Negative 2 times 5 is negative 10, plus 6 is negative 4. And then plug in 6, negative 2 times 6 is negative 12, plus 6 is negative 6. So I'm pretty much all set, and I can go ahead and plot my points. One thing I'm going to keep in mind though, this one is the one that we're allowed to equal 4. So when I graph 4, negative 2, that is going to be a solid point. I'm going to circle 410 because when I graph the point 410, since it's in this first piece, these are all values less than 4. So I'm going to be putting an open circle when I graph that one. So I'm going to go to 410. I'm going to put an open circle, and then 3, 6, and then we'll do 2, 2. Okay, and we know that that's for everything happening before that. So when I connect those, I'm going to do my best here. I am going to make a line just continuing down because that will just keep going for every value that I pick. And that's supposed to be a straight line, of course. Right, now when I go and do the next one, we have 4, negative 2, 5, negative 4, 6, negative 6. Okay, and we know it's going to be a line. This one does get a filled in circle, and then again it's going to continue on. So that's what my piecewise function would look like. Alright, the next example for graphing a piecewise function, if you'd like to pause the video and try this yourself, that would be great. But I'm going to go ahead and separate it into 3 parts. So we've got negative x is one of my parts, we've got x squared as a second part, and then we've got 1 as a third part. So just about thinking at this, I know that negative x is going to be a line headed in with a downward slope, x squared is going to be a parabola, and then 1 is just going to be a flat line straight across. So the first one is going to be all values less than 0. So I will go ahead and make a graph. So 0, I'm going to circle this one because since it doesn't equal 0, I know that that's going to be an open circle. And then values less than 0 would be negative 1, negative 2, and I think that's probably good enough. Then my second graph is going to be, this one has to start at 0 and go to 3. So I'll put 0, 1, 2, 3. And for 0 and 3, they're going to equal 3. So those will be closed in circles when I go to graph it. And then the next one is going to be x is greater than 3. So starting at 3, 4, 5. And again, I'm going to circle 3 because x has to be bigger than 3. So I will need to do an open circle there. All right, so let's go back to here. When I plug 0 into negative x, I'll get 0. Negative 1 will be 1, and then negative 2 will be 2. My next part, 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9. All right, and then my last one, if I plug in 3 into 1, it's always just going to be 1. All right, so now I'm ready to graph. So we're going to have a point at 0, 0. It's going to be open circle, right? And then we're going to have negative 1, 1, and then negative 2, 2, and then we know that that pattern is just going to keep going. Okay, the next one, 0, 0. Notice now I'm going to actually get to fill in that circle. Okay, so 0, 0. We've got 1, 1. We've got 2, 4. And then we've got 3, 9. All right, and we do want to make sure that we do make that look like a curved parabola. So hopefully we can tell it does. Whoops, I should have stopped right there though. So it should not have gone any farther. So don't include that. And then 3, 1 is an open circle, and then 4, 1, and 5, 1. Well, that should have happened at, yes it did, okay. And then we know that that's a line going straight across. Okay, so that's what that second one would look like. All right, another one, this one's a little different because instead of having less than or equals, we have not equal to and equal to. This one would be when x squared plus 3 when x doesn't equal to, and 4 when x does equal to. So we still have 2 parts going on here, they're just a little bit smaller. So those are my 2 functions. On this one, when x doesn't equal 2, so we could do like 0, 1. I still am going to put 2 in there, and I'll tell you why in a minute, and then 3, 4. I'm still going to put 2 because everything, I just want to make sure I can capture what's happening around 2. This will be an open circle. I can still put a point there, I just can't close it in. And then for this one, the only value I can put on my table is just at x equals 2. So now when I go to fill these in, 0 squared plus 3 is 3, 1 squared plus 3 is 4, 2 squared plus 3 is 7, 3 squared plus 3 is 12, and 4 squared plus 3 is 19. All right, and then this one, when x equals 2, we know simply that y is equal to 4. So now I'm ready to graph that first one, 0, 3, 1, 4, and I can again go ahead and graph 2, 7, it just needs to have an open circle there. 312, and 419. I'm just estimating, of course. And now we know that because it's an x squared graph, it is going to be a parabola. So I'll try to make it look like that. And this can keep going because it's as long as x doesn't equal 2, that's what's going to happen. And actually, I guess we could probably go this way as well because it's just going to be anything that doesn't equal 2 would work. And then I will graph the point 2, 4, and this one actually will get a closed circle. So you'll notice we've just got a hole going on. We'll discuss that later in a different section, but that's what that graph would look like. Right, the last one that I just wanted to quick show you about was the absolute value function, that it actually is a piecewise function. If you look at this first piece, when x is less than 0, we have the line y equals negative x. And then when we have x is greater than 0, we have the line y equals x. So we actually can break that up into a piecewise function. So we're going to have f of x equals negative x when x is less than 0, and then we're going to have f of x is equal to x when x is greater than 0, and we can put the equal sign, both of those will get a dot. We can really put the equal sign on either one. I am going to put it on the second one. So that would be the absolute value as a piecewise function. So hopefully now you're familiar with what a piecewise function is, how to evaluate it, and how to graph it.